Good morning, good afternoon, and good evening, whenever you're watching this or wherever you're watching this. Welcome to a new edition of OTel in Practice, where industry experts, end users, and contributors tell us about a specific area of OpenTelemetry and how it can benefit, or it has already benefited, end users. My name is Dan. I'm a member of the End User Special Interest Group, and I'm also a member of the Governance Committee. And I'm very excited today to have Huxing and Steve to talk about adoption of OpenTelemetry within Alibaba. I'm connecting from Edinburgh in Scotland. You can see the hills here. And if you're watching live on YouTube or LinkedIn, please say hi in the chat and tell us where you're watching from or where you're connecting from. Before we get started, I just wanted to cover a couple of housekeeping items. During the presentation, please drop your questions in the chat. And although we'll make our best to get to all of your questions, I can't promise that we'll get to all of them. But fear not, if that's the case, if we can get to all of them, and your question is not answered, or you want to continue the conversation, you can go to the end user SIG, and then we've got resources in this link, and you can continue the conversation there. You find your way to Slack, where we have a big community of end users, including Huxing and Steve, and we will be happy to go and provide some of the insights there. Also, please remember to keep the questions today in topic of the presentation. And yeah, so with that out of the way, let's get started. And welcome Huxing Zhang, staff engineer at Alibaba and OTel compile instrumentation maintainer. Hi, Huxing. Can you tell us a bit more about what you do?
Hello, Dan. Very nice to meet you. And hello. I'm Huxing. I'm from Alibaba. Yeah, I'm working on as an observability engineer in Alibaba Cloud, and we are also most working on the client instrumentations. So we work very closely with the OpenTelemetry community. We're working on different kinds of language instrumentations, collectors, and something like that. I also provide service both for internal and external clients, customers. Thanks.
That's awesome. And also welcome Steve Rao, senior software engineer at Alibaba and OTel Java instrumentation approver. Hi, Steve.
Yeah, hi, Dan. Hi,
Hi.
everyone. I'm Steve. I'm also from Alibaba Cloud. I'm working in observability team in Alibaba, and I'm participate in Java agent, and I also responsible for profiling in our team and provide out-of-box profiling ability for our users. Thank you.
Nice. Well, welcome both. I'm really excited to hear more about how you're approaching OpenTelemetry in Alibaba, and how you ended up contributing as well, being major contributors to OpenTelemetry. So now that we're all set, you've got a presentation and you'll guide us through it. I'm going to move out and then please take it away.
Okay. Hello, everyone. We are Steve Rao and Huxing Zhang from Alibaba. And we are very glad to share our talk, Alibaba practice experience today. We will explain our talk from following 5 parts, and I will introduce the first 2 parts, and the remaining are given to my colleague. The reason for choosing OTel. Let me briefly introduce our background. In 2013, we have provided observability capability for our internal users by manual instrumentation. And we provide this ability into our internal software frameworks. And we also designed a set of trace propagation protocol called Eagle Eye. And in 2017, we developed our Alibaba Java agent based on Pinpoint Java agent. After several years of use, we found some problems, such as Pinpoint cannot support verify the supporting version of a framework. For example, if a framework released a new version and the instrumentation may not take effect, and we can perceive this immediately. Another thing sounds like Pinpoint cannot support very well in some scenarios, such as trace propagation asynchronously. It doesn't support it automatically. And there also have some other reasons. Due to the limited time, I cannot list them one by one. So from 2020 to 2023, and we researched some other solution from open source. At the time, we found OpenTelemetry is a very strong ecosystem. It has reached OTel semantic convention, and it represents de facto standard in observability. After several internal discussion, we made up the mind to migrate our Alibaba Java agent from Pinpoint to OpenTelemetry. After several months of development, and we launched our Alibaba Java agent based on OpenTelemetry. In 2024, we also launched our Golang and Python instrumentation based on OTel semantic convention or SDK. Currently, we embraced OpenTelemetry completely. After introduce our background, during our migration, we really did a lot of enhancements on OTel Java agent. The first one is instrumentation. At the time, we found OpenTelemetry may have not widely used in China because there are some frameworks that are not support from OTel Java agent, but they are widely used in China. We have supporting them before, so we need to implement them based on OTel Java agent architecture. And the second point is profiles. As we know, profile is very powerful too. It can help us to inspect the behavioral performance of our application at runtime. It can help us to know which code is responsible for the spikes in CPU memory usage. We have supported profile for several years, so migration of this feature is also very important for us. Other abilities such as abundant sampling or more metrics, and we also need to debug a very popular debugging tool RSAS in China. Last but not least, we not only support observability by Java agent, we also support microservices governance, such as traffic control or security management by this Java agent. So how to compile them in OTel Java agent architecture, it's a task we need to solve. Introduce the enhancement we need to do, and due to the limited time at the time, and how to migrate them, it's challenging for us. In fact, at the time, we don't very familiar with OpenTelemetry, and in order to achieve this goal, we come up with a two-step solution to solve this question. First one, we forked a copy OTel Java agent repository, and we promptly implement all our commercial enhancements on the Java agent. In this process, it's not very easy because there are a lot of commercial features. If we migrate to the OpenTelemetry, there are a lot of issues or problems. And due to the rich business scenarios and during migration, we also found some problems, and we need to fix them, solve them, and some of them are strongly related to the upstream. We also contributed them to the upstream. After about 6 months from research to launch the first release of our Alibaba Java agent based on OpenTelemetry. After finishing this phase, and we know that is not enough because we know the biggest charm of OpenTelemetry is its stronger ecosystem. So, if we compare our code compare with open source, yeah, it's challenging for us to merge some upstream update to our Alibaba Java agent. So we, on the one hand, we promote our user to use our first version, and then we also invite some developers to to design some extension or use some extension from open source to migrate our commercial feature. And this process is time consuming because we need to design some extension based on OTel Java agent. And we also need to contribute then to the upstream. And there are the things that we are have been doing currently. And after this step, we can theme the open source OTel Java agent just like a dependency for us, and we can decouple our commercial code and the open source code, and we can merge upstream easily. Yeah, this is our whole approach to achieve migration. After migration to OpenTelemetry, we really get a lot of things from open source, and we also get something we doesn't anticipate at the beginning. The first one I want to share is OTel semantic convention. Yeah, I guess that is the soul of the OpenTelemetry. And when we migrate to OpenTelemetry, and we tell our user we achieve this Java agent based on OpenTelemetry, and they can do a lot of things by themselves, such as they can search some materials, search some documentary by themselves, and they can learn how to use some extension to write something by themselves, and they can debug some problem by themselves. I think that is very good point for us to embracing OpenTelemetry, and our user can do a lot of things by themselves, and it's really reduce users' learning burden, because they just need to learn the standards, the semantic convention, or implementation of OpenTelemetry, and they can do a lot of things by themselves. Yeah, this is the first point. And the second point, good architectural design and better scalability of OTel instrumentation. That is very useful for us to promote our users to use our Java agent. How to understand this? For example, before OTel Java agent, and if a user use a framework that is not widely used, and we don't support that framework from our Java agent, and they will create an issue for us and ask we to schedule resource to support this framework. But sometimes we take the cost and take the energy into consideration. We are reluctant to support that. So how to communicate with our user, that is a question at that time. Nowadays, this is not a big question, because we can tell our user there are a lot of extension. You can use this extension to support your own framework, and you can do it by yourself. And a lot of users, they are very interesting about this, because they can extend a lot of things by themselves, don't rely on us. And it's not only use our, but all our set. That's other bunch of get from telemetry. Each time so things I want to share today, and remaining time I'm going to introduce something from other aspect. Thank you.
Thank you, Steve. I will next to introduce. Hello, can you hear me very well?
Yeah.
Okay, sorry, there's some network issues. Maybe I just lost the connections. I will go into for the remaining part. Yes, actually, this solution has been started in 2023, and at that time we want to looking for a solution that can be easily for Golang applications for to do instrumentations. Actually, when we are um, we're trying the eBPF based approach that is already been provided by the OpenTelemetry community, but it turns out that there's something some limitations there, and we finally we have figured it out the way that to do the instrumentations to satisfy our needs. That is in a compile time instrumentation. If you're looking at the figure in the right, there's a approach that the injection has been happened in the middle of the compilation process. Actually, we hooked the Golang compile command and to make sure that can be done for users. There's no modifications to users code. So that's a key feature that we want to achieve. And next, I want to address several highlights of this approach. First is the async context propagations. Actually, the users we encourage them to follow the guidelines, but actually not all the users follow the rules. So because they do not pass sometimes they do not pass the context object correctly, the traces may break and become incomplete. So this feature can do the context propagation automatically for us, even when we are not passing the object correctly. The second one is it's actually compatible with the OTel SDK. That means that users have used the manual instrumentations. They can work well with our approach. So the traces can be merged. And the last one is I think the most powerful features that we have done is kind of like customer extension. That means that you can instrument any code into any point, any line of that applications. And this allows us to solve some special requirements from users. Then they can do some customizations like traffic management and security. Yeah, please. Yeah, that's what I think is very important. And next, we will introduce some practice that we have in the LM observability. As we know that the LM has been popular recently, especially this year, where a lot of AI agent has become active. And there's a typical use cases that we found in the use cases is a user send a request to the API gateway, and the API gateway sent it to the LM applications, which is written in maybe Python, Java, or Golang, and the application will call different kind of models, for example, DeepSeek, Queen, or OpenAI, and there's actually we have adopted like an AI gateway in the middle, and which can do a lot of things for us. For example, they can do unify the access and do token limitations, token cache, and all stuff like that. And so we have adopted the open source project called Highgrass that can do it very well for us. So actually, when we are building the observability across the different kind of components, we make sure we're following this latest GenAI semantic convention, and because the convention is still in development, we're trying to keep the pace with them as much as possible, and we have done some instrumentations based on this semantic convention. This includes major AI agent framework, like high code frameworks like Agent Scope, Agno, LangChain, Spring AI, Alibaba, and etc. And for low code platform like DeFi is a very popular open source project to build AI agents with low code. And we also do some instrumentation for the official MCP clients. For example, we want to capture the MCP2 calls. We want to capture the MCP2 responses, and to make sure our observability is end to end. So we want to put our instrumentations into the internal models that brings up with serving framework like VLM or SGLang. Is actually they are a Python process running there, so we can put our Python instrumentations into that Python process to capture traces and key metrics like TTFT, time to first token, and TPOT, time per output token, which is very important metrics for us to identify bottlenecks of LM serving issues. Yes. Next, please. Yeah. Talking about the adoption cases, actually, we have many adoption cases. Today I want to introduce several of them. I divided into two parts. The first part is the cloud service data flow, because when users they are using cloud service, make sure all the services that in the key positions of the applications also they embrace the official W3 tracing protocol by default. That means that balancer way or they have support the telemetry W3 tracing protocol by default. We'll have the message service they're using OpenTelemetry, the async messaging, like how a consumer is consuming the message as well, and to measure the latency or identifying the bottlenecks, they are using OpenTelemetry to do that. And for the AI Studio, I mentioned in the previous slides, and they are using actually Java and Python OTel instrumentation for end-to-end observability. And the part two is the cloud service management console. Actually, a lot of management console service has embraced the OpenTelemetry as well. For example, the Elastic Cloud Computing Service, they're using OTel Java instrumentation quite a lot, and they make some extensions to that, and they want to do like request-based traffic routing. They want to route the service to different machine groups and then they actually done a lot of things beyond the instrumentations. Yeah, the video on-demand service also they are running large amount of clusters written in Golang, and they have adopted the Golang compile time instrumentation, and they mostly for the runtime monitoring. Yeah, they want to monitoring the runtime metrics, also providing data. And another case is the instruction detection service. Actually, they are there's a agent running on a host. They're written in Go, and they want before OpenTelemetry they have nothing to do with the observability because they lack of techniques, lack of tools to do that. Now they can use OTel Golang compile time instrumentation for their runtime and monitoring and providing. And last, we as our own service, cloud monitoring service, actually are also implement self-observability with Java instrumentation. We do a lot of things with Java instrumentation to do traces and providing, yes. And this is good example of dog fooding, right? Yeah. Next, please. Yes. Besides our internal adoption, we also trying to contribute this enhancement or extensions back to the OTL community. We actually have mentioned in before a lot of instrumentations, and some of them has been contributed, and some are also on the way of contributing back. Yes, we also helped to promote OpenTelemetry in the APAC area. We help to organize some meetings that is friendly to the APAC, Asia Pacific areas like Java, Go, and GenAI meetings. And we also engaged with the conference like KubeCon and OTel Community Day, and we're also organizing events like KCD and to help to promote the open telemetry in Asia Pacific areas. Yes. And in 2024 is when we have decided to donate this Golang compile time instrumentations to the OTel community. And after a long discussion with the community, and we also found that Datadog has showed a very strong interest in this project, and they also submit a proposal to donate their Austrian framework. Is also a compile time instrumentation project to OpenTelemetry. So we decided that we do not depend on single one company effort from single one company, but we form a SIG and to build this project from scratch. And so this SIG is co-founded by the Alibaba, Datadog, and Quesma to we have a common effort to implement this compile time instrumentation for Golang, and this project is still in active development, and we are going to we are working on the first release, and we are working on the first MVP version of that, and this year, yes. And if you are interested, yes, please definitely check it out. And talking about the future work, yeah, for Java instrumentations, actually we are planning to implement the proxy agent mode. That means that we want to use the OTel Java agent as a dependency rather than forking the upstream project, because we do not want to maintain such kind of project. We want to make sure all the extension point can be merged into the upstream so that we can extend this project very well. So for the Golang compile time instrumentation, yeah, we are working well with the MVP version, and we're making sure we are very in the first release, working towards the first release. We also will support for more signals, including metrics and profiles. Yeah, for GenAI, we also want to contribute on some of the instrumentations up to the community, because this GenAI is still in active, the semantic convention is still in active development. Yes, we put some of them in our repo, and we want to uh, contribute in the back as well. Yeah, actually, we also have our own OpenTelemetry distribution. Is called Long Suite. Long is for Chinese version of Dragon. Long, yes, yeah, it's kind of distribution built on various language instrumentation, as well as our collector project called the Long Collector. Yeah, so we want to make sure that all the enhancement we want to trying to put them contribute back to the OTel project as much as possible. But for some reasons, the community may not accept our contributions. They will be in our own distributions. Yeah, and that is all for the presentation. And thanks for everyone for listening. Yeah.
Thank you. Thank you, Huxing and Steve. That was great. I think, yeah, feel free to drop any questions in the chat, and then, if you're watching live on YouTube or LinkedIn, have one, which is, you mentioned like adoption of OpenTelemetry within Alibaba, and I wanted to know how easy was it for teams within Alibaba to migrate to OpenTelemetry? Is there anything you can share in terms of facilitating a migration? Maybe they use something like a common set of libraries or migration scripts now with code generation or something else.
Yeah, I think it's not quite easy. Actually, it's not quite easy for them to migrate. We have done a lot of things to advocate for that. First, we wrote some like articles internals, and to share some of our practice, how like a kind of team they adopt this technology and how they benefit from that, and then we put that into the internal article, and to help them to promote this OpenTelemetry. Secondly, we want to try to minimize the effort for the user to migrate from, because we have a legacy project called Eagle Eye, and they already have some instrumentations there. If they are switching to this legacy architecture to the auto instrumentations, they might encounter some conflicts or something like that. We have done a lot of things to prevent such kind of things to happen, and we build that within our agent, our instrumentations as much as possible, and to make sure the users have minimized their effort to start up and to migrate. I think this the idea is to try to put things to our team rather than put the efforts to the users, to make sure that seamlessly migration from the legacy architecture to the OTel-based one. Yeah.
Nice. So you like dog food in that, so to make sure that you adopt it internally as well. Yeah.
Yeah.
Yeah, that makes sense. Okay. I think we've got some comments on the chat, but no questions so far, as I can tell. I have another one as well from myself. You mentioned that you run on the OTel Java agent stuff. You run a fork or a distribution of that agent. But in terms of API usage, do internal users in Alibaba use the OpenTelemetry API directly when they instrument their applications, or do you have some kind of abstraction on top or a helper library that that they use instead of the OTel API?
Yeah, I think for most cases, we would them to use the auto instrumentations as the first choice, because that is less effort for them to start their adoption. But for some special cases, actually we can't satisfy it, so we will encourage them to use the SDK one to add some custom instrumentations. For example, they want to add some custom spans or metrics. So when that, we encourage them. Normally, we use the official OTel SDK as much as possible, because that is well documented, and we battle tested with the latest version of that SDK. So we do not want them to build another abstraction layer on top of that. But there's special cases that we introduced in LLM application observability recently. Actually, our AI studio that they are using the OTel SDK. They found it that they have to write a lot of code in order to add their instrumentations, because there's so much things that want to capture in a span. They want to capture very in detail, want to capture a lot of things. So they have to write a lot of instrumentations. So they ask us to, we can provide an abstract layers for them to simplify their work, to do their instrumentation. So in that case, we actually work with them to provide a higher level of that SDK. So that did work, because their instrumentation effort have been reduced, and they are very happy to do that. Yes, so that is one case I think I can share, and for most cases I think it's using official OTel SDK.
Yeah, and in terms of the API as well, because it's got that decoupling of the API and the implementation, you can always swap the implementation underneath with the SDK, right?
Yeah.
So,
Okay, I want to share another point about this question.
Sure.
Yeah, for our internal users, some of them, if we don't provide auto instrumentation, such as C++ application, and we encourage them to use the API, just like Huxing mentioned. And another point for Java application, some users, as we know, if they use trace or span, sometimes there is a monetary block spot. If we just instrument some framework, some key methods, and if the latency belongs to users' code, maybe they can get the information why the latency is so long during the two trace. At this time, we provide out-of-box profiles ability. We correlate the trace with profile, and we can provide diagnose for users to understand why the latency is so long, which code responsible for the latency. So they don't need to use the API to instrument their own method manually.
Okay, yeah, that makes sense. Okay, last question from me, and again, the audience, if you're watching and want to drop a question, feel free. Both of you talked about context propagation as something that has definitely improved a lot thanks to OpenTelemetry instrumentation, and I know this from experience, especially when we're talking about async tasks. However, sometimes it's still challenging in certain scenarios to make sure that internally in a service that the context is propagated correctly. How do you encourage teams to ensure that context is propagated correctly within not just across services, but also within their own services? And also, like, do you know that they measure that in some way? If if context is broken somewhere or leaking?
Yeah, that's a good question. Actually, I think for our internal users, it's very difficult for them to, like, even if you provide like guidelines or encourage them to do so, they may not follow this rule, and then there's very much opportunity for them to miss that or to fail to follow that. So I think to solve this problem is our team's duty to make sure all the possible ways of facing cross propagations has been propagated correctly by our auto instrumentations. That is where we solve this problem. So we have the popular frameworks, for example, in Java, the thread pool, or the some kind of similar scenarios, and we do the test to make sure that in the bottom of the technique, they can be async context can be propagated properly. Yes, and this is another frameworks. It's very challenging for us to do so. For example, the Reactor, Netty, or such a kind of frameworks. Actually, they are very high frequency for them to switch in context, and asynchronous is common for them. And for these kind of scenarios, we might have something working not very well or as expected. For this case, we will like to try to work with the community, or want to solve it first of all, to figure it out by ourselves, and we at the same time we will seek help from the community, and to trying to identify the issue and try to fix it. And this is the common cases, I think. And then
I used to remember the days where you had to pass a context object around in function calls, and it wasn't pretty, and it wasn't good either. So yeah, I think auto instrumentation is anything that can get done transparently is also, it's always going to be covering more and resulting in better context propagation, right?
yeah, as long as the users has stick to that automatic instrumentation approach, they will like to ask for that. Have you satisfied this, or why did that happen? So they will come to us and looking for help rather than do it by themselves.
Indeed. Okay, I think that's all we had time for today. Thank you so much for joining us, both Huxing and Steve. It was great, like, knowing more about Alibaba's approach to OpenTelemetry, and thanks for all that joined live in LinkedIn and YouTube. And so we've got remember that if you want to continue the conversation, we've got the end user SIG resources as part of the OpenTelemetry.io website. And feel free to continue the conversation there. And hope to see you there as well. And thank you again, both. And see you in the next one.
Thank you. Bye bye.
Bye.